A very good afternoon to all of you. Welcome back to this class. So now we are in the second semester classes. We will be continuing with online mode for theory and offline mode for practicals. So my portion will be the section 2, that is organic chemistry, unit 3. I'll be taking unit 3. We have 2 units in organic chemistry. One is unit 3, which include nucleophilic substitution reactions and then elimination reactions, alkyl halides. Now all these 3, A, B and C, they are actually part of the reactions of alkyl halides. And then we have the D, this is supposed to be D, aromatic halogen compounds. And in unit 4, you have the alcohols, the glycols, the phenols, aldehydes, and ketones. So Sir BK will be taking this part. So we will take a look at the nucleophilic substitution reaction first, and we'll go into the elimination reaction, and then on the general reaction of alkyl halides. So what is substitution reaction or nucleophilic substitution reaction? Before we go into the detail of that, let's have a look first at the types of organic reaction that you have encountered and those which you will be encountering in this semester and also in other semesters. So you have the most common organic reaction is the addition. Addition reaction is one of the most common reaction, which there can be 3 mechanisms. One is the electrophilic. We have the electrophilic type of mechanism. Then we have the second one, that is the nucleophilic. So we have the nucleophilic, and the third one, which will be free radical. Now 2 of these you have encountered. The addition, the electrophilic addition, this one you have encountered in the alkenes and alkynes reaction, which like say addition of HBr, addition of HCl, so those you have encountered. Free radical also you have encountered in alkenes. Okay, then the second type of reaction that we commonly found in organic reaction is the substitution. Substitution. Addition means you have a molecule and you add an extra group into that. So this will usually be unsaturated compounds that can undergo addition kind of reaction. Now substitution reaction on the other hand can be either unsaturated or unsaturated groups. So we have the first type, that is the electrophilic. Again, here we also have electrophilic, nucleophilic, and also free radical. So you also have these 3 common substitution reaction. So electrophilic, we have the electrophilic, especially on the aromatic compounds, which you have seen in the first semester. Then we have the nucleophilic, and then we also have the third one, that is the free radical type of substitution reaction. So electrophilic is common in aromatic, where you undergo substitution like halogenation, nitration, sulfonation of a benzene or any aromatic compound. Free radical is the substitution like the alkanes, like say bromination and chlorination of methane. So if you remember, CH4 will react with Cl2 in presence of light to give you CHCl3, or it'll be, there actually multiple product can be obtained, say CH3Cl and so on. So we have encountered these reaction in your first semester. Now in this semester you will come across the addition nucleophilic type of addition. This will be on carbonyl compounds. So Sir BK will be discussing on this. So this will be on carbonyl. And also the substitution nucleophilic, that is substitution nucleophilic type of reaction. which are usually common on alkyl halides. So when we discuss nucleophilic substitution reaction, we are also discussing side by side the alkyl halide. So they are related to so the substitution reaction, nucleophilic substitution reaction, are very common on the alkyl halides also. Then the third type of reaction that we will be taking a look, so this one you will have not come across in your first semester, maybe in the preparation of alkenes. So maybe you have come across in preparation of alkenes, but in general as a study you have not done that one. So elimination type of reaction. Now this one can be of two categories. It can either be base catalyze, or it can be acid catalyze. So we will be discussing this in this semester. The base catalyze reaction, which is very common on, again, alkyl halide. So we'll be taking a look at the mechanism. We have a different mechanism for that. And the acid catalyze, these are mostly common in alcohols. So Sub BK will be dealing with this part. So these are very common reaction for organic chemistry, and most of them you have learned in your first semester, and also you'll be learning in this semester. Now there are also some reaction which you'll learn somewhere in this semester or in the next semester. So there will be some special reaction like rearrangement. These are more special kind of reaction, and also oxidation and reduction. So we can also have oxidation and also reduction type of reaction in organic chemistry or organic reaction. This is just a general idea about the type of possible reaction in organic molecules. Now we will take a look at this reaction which I have told you that we will discuss, that is the substitution, and the second one, that is nucleophilic substitution. And later as we proceed, we will then go on to the elimination, base catalyze type of elimination, which involves the alkyl halides. Now you can see here this involves alkyl halides, so this also involves alkyl halides molecules. So before we go into the substitution reaction or the nucleophilic substitution reaction, let's have a look at the common reagents. We have seen about this reagent in the previous semester also. Just about this, the electrophiles. We have the electrophiles, and then we have the nucleophiles, and also we have the free radical reagents. So you have a molecule that will undergo reaction that is called as a substrate. So you have a molecule, say alkyl halide, and then you'll have these reagents which are called as either electrophiles, nucleophiles, or free radical. So if it is involving a nucleophile, I'll just represent that by an Nu. So this will be the nucleophile that will react with the substrate. So you have the substrate on this, and you have the reagent on the other side. So we have the substrate and the reagent, they can undergo reaction. So depending upon the reagent that you use, then the name of the reaction can also be derived. Like for example, if you use a nucleophile, then it is a nucleophilic type of reaction. And if it is, say, a substitution, then it is a nucleophilic substitution. If it is an elimination, then it's nucleophilic elimination. If it is an electrophile, then you call that an electrophilic type of reaction. So it could be again substitution or elimination. And it's a free radical, also that's a free radical substitution reaction. So here we know that by definition, what are electrophiles? Electrophiles, they are electron deficient, that is one thing. They lack electron, so electron deficient. That is one thing. That means the reagents, they have less electron. They can be positively charged, it can be neutral, it can be positively charged. So they can be positively charged also, or they can be neutral also. And they can be atoms, or they can be groups. So it could be any of these. Neutral molecule also. So all those molecule which or groups or ions which are electron deficient, they are called as electrophile. I think we have discussed about electrophiles and nucleophiles, all these reagents in the previous semester. Say for example, say hydrogen ion, this is an electrophile, and then nitronium ion, so this is an NO2 plus, and then a carbocation ion. Now all these are electrophiles. Say chloronium ion, bromonium ion, and so on. Now these are all charged, that means they are positively charged ions. Now they can also be neutral, like say for example we have say aluminum trichloride. These are electron deficient, it has got an empty orbital there. Boron trifluoride, and then we have say Br2, which can undergo bromination type of reaction. Carbon dioxide. Now these are also are electrophiles. So SO3, all these are electrophiles. Nucleophiles, on the other hand, they are electron-rich species. So just the opposite of electrophiles, we have the nucleophiles. So this is electron deficient, this is electron-rich. They can be neutral, they can be negatively charged. That's again, it could be an atom, it could be a group, or neutral molecules. But they have lone pair of electron. If they are neutral molecule, they should have lone pair of electrons that can interact with electron deficient groups. So here the example can be groups like say OH minus, Cl minus. You can see that CH plus here, OH minus. Cl can be electrophile, it can be a chloride ion, it can be a chloronium ion. So depending upon the charge, you can have also say Br minus, you can have OR. So all this with negative charge, say RNH minus, all these are nucleophile. Say Cn minus, all these are nucleophile. Then you can also have neutral molecules like water molecule with lone pair of electrons, alcohols with lone pair of electrons, and then you can have say ether with lone pair of electrons, ammonia, amines, so primary amines, secondary amines, and so on. So all these can be nucleophiles. And we can also have the free radical. Now free radical, they simply are groups that has free radical which contain an unpaired electron, like say for example Cl free radical, or most commonly we have say the C6H5 also as a free radical. We have these reagents, we have the electrophiles, we have the nucleophiles. Our interest is more on the nucleophiles because we will be discussing about nucleophilic type of substitution reaction. So we'll take a look in more detail about these. Now nucleophiles, they are electron rich species. They can be negatively charged or they can be neutral, can be an atom, can be a group. So in other words, if you take a look at these groups, they can also be bases. So nucleophile can also be base at the same time. So if depending upon how it react, if it react with a substrate like say an alkyl halide, you have a nucleophile, say OH as the nucleophile, if an OH react with an alkyl halide, see, it form a new bond with a carbon atom here. Form a new bond with a carbon atom, so it become ROH, and this is removed. Now in this case, OH behave as a nucleophile. So here it behaves as a nucleophile. But if, say, OH, which is also a very strong base, react with or it take away one hydrogen ion, say for example from ROH or from any acid, so this is picking up this hydrogen ion. Now here it behaves as a base, so it becomes RO minus H2. So here this one behave as a base. So that means the nucleophile can also be a base at the same time. So in general, we can say that all nucleophiles, in fact all nucleophiles, they are base if they accept a hydrogen ion. That means they will pick up a hydrogen ion from any acid. But if they interact with a carbon deficient, electron deficient carbon, that is an electrophilic center, then it behaves as a nucleophile. So nucleophile will be reacting with an electron deficient carbon. Electron deficient carbon atom. Whereas a base will interact with a hydrogen ion, or will pick up a hydrogen ion. So these are the important things that you should know before we go further from here. So one more thing, acid-base reaction is always in equilibrium. If you remember in the first semester, we have taken a look at the Bronsted and Lowry concept of an acid and a base. So we have a base react with an acid HA. Now this is always in equilibrium. So we have A minus plus H A plus H BH plus BH plus. So this is an equilibrium reaction. So the reaction is determined by equilibrium factor. Equilibrium factor. So the strength of a base is determined by this one, like pKa. So pKa is an equilibrium factor, or pKb. So pKb or pKa. Now most commonly we use pKa for the strength of a base. But for a nucleophile, it is not an equilibrium reaction. It proceeds in one direction. It's not a reversible, and it's not in equilibrium. So here it is determined by a kinetic factor, like in this case determined by kinetic. How fast this one will react with the carbon atom and form the product. This is known as a kinetic factor. So the rate of the reaction, it depends on the rate of the reaction. So it is determined by the rate of the reaction. Here it is determined by the rate by this pKa values, which is an equilibrium constant in this case. Okay. So we have seen about the reagents, that is the electrophiles and the nucleophiles. The nucleophiles can also behave as a base, and if it acts as a base, it will abstract a hydrogen ion. But as a nucleophile, it will react with an electron deficient carbon atom in this case. Now let's have a look at one important part of nucleophile. We have also what are known as ambident nucleophile. So what are ambident nucleophiles? Now a nucleophile can attack an electrophilic center. Like in this case, you have the OH, it would attack the electrophilic center, that is the carbon atom in this case. So this carbon atom is electron deficient in nature. So this will attack this one. So it has got one point of attack, only this oxygen atom. Now let's have a look at this example. Chlorine has got only one point of attack, so only from this chlorine, from bromine, and then this OR also, it's only from this oxygen atom. NH minus is also from here. Now H2O is also again only from this oxygen. ROH is also again only from this oxygen. This ROR or an ether again only from the oxygen. NH3, it's only from this nitrogen, and so on. Now there are certain nucleophiles which contain two sites of attack, not only one. Say for example a CN group. You have a carbon and a nitrogen. So you have a negative charge there and you have a lone pair. So this one can either attack an electrophilic center from the nitrogen or it can attack from the carbon. So this kind of nucleophile, they are called as ambident nucleophile. Ambident come from what? Ambidentate, bidentate, which means two teeth. Dent means teeth. So it has got two teeth for attacking. So nucleophile having more than one nucleophilic center. So these are called as nucleophilic centers. So if you have got more than one nucleophilic centers, they are called as ambident. So two common example of ambident nucleophile is CN group, and another one is an NO2. So you have an NO2 group. So this one also can either be from this oxygen, or from the nitrogen that it can attack. So these are called as ambident nucleophile. So we'll conclude here for today, and in the next class we will take a look at the different substitution reaction mechanism. Thank you.